Okay, hello everybody. Welcome to the grade 9 hour of the freemathhelp.ca live stream. I hope you are all having a wonderful day so far, and I hope that you are safe and healthy during this time that's going on. So without further ado, we're going to get started. I'm just going to listen back to the sound really quickly to make sure that my voice is coming through okay, and then we're going to get started right away, okay? Okay, so I've turned the sound up a little bit just because I felt like it wasn't coming through perfectly, it's just a little bit loud, although it is better than it was at the beginning of last week when we had a bit of echo. So if on your computer the sound is coming through wonky, please feel free to leave a comment in the chat just so I can know and try to fix that. But yeah, so we're going to get started. So today we've had some questions submitted that have to do with the analytic geometry unit, or as a lot of people know, just the linear equations unit, which is all about y equals mx plus b and all of that fun stuff. So I am going to address those in just a second here. Now, when questions do get submitted and we see that they are from assignments, just because we work with a lot of the local schools in Simcoe County and the GTA, we try not to give the exact same question, but I will answer these questions in a way that is pretty much exactly like the questions you've gotten, just not with the exact same numbers. Okay, guys? So we're going to start off with this question. I'm just going to put this up here. So the question says, graph the lines using x and y intercepts. Make sure to clearly label. Okay, so let's take a look at the questions that we've been given. So I'm just going to get my handy dandy pen over here. Pick a nice color. Let's start with this lavender. So the lines that we're going to take a look at today are going to be in what we call standard form. So as we remember, if you've been tuning in previous weeks, there are three different ways that we can actually look at linear equations. Okay, guys, so I'm just going to quickly go over those three different ways that we can talk about linear equations. So I'm going to put them over here. So the first standard form that we talk about, like this one here, this is standard form, kind of. We still need to fix something on it. But the standard form comes in the following exact, we'll say formula kind of. So we have a number that we call a in front of an unknown variable x, plus a number that we call b in front of an unknown variable y, and then just a number by itself called c. Okay, there is another format that we use for lines, and that one comes in the form of the the slope intercept form. And that is just our standard y equals mx plus b. And everybody really likes this slope format because these particular unknown variables in here tell us a lot of information, like the m stands for the slope, which basically tells us how high and how far each line is going up and over. And then the b is our y-intercept. Now, with our standard format that we have over here, that I've drawn here, we don't have that same amount of information, but we can actually gather that information by using a couple of tricks. So one thing I want to make sure that we understand is, what does a y and an x intercept mean? Okay, and I know that a lot of you who are learning this outside of the classroom, or who didn't get the chance to learn this before we started doing distance learning, this is actually kind of quite a difficult concept for grade 9. because we've never really been exposed to this concept before, and then we're expected to use it on so many different fronts. So what's very important to understand are two key things. So an intercept literally is just a way of saying where the line crosses a certain border. So let's say, for example, not with regards to this line that I've written over here, but let's just say we're asking about an intercept for any line, right? And we're asking about the y-intercept. What we're really asking is, where does the line cross the y-axis? Okay, so this is the y-axis where I'm drawing this little orange arrow. And all the way down from top to bottom, that whole thing is considered the y-axis. And when they're asking us about the y-intercept, they're really just asking us at what number on the y-axis does the line cross the y-axis border. And we actually have some very cool ways of figuring that out. And in this unit, your teacher is going to ask you how to figure that out in a bunch of different ways. In this particular question, what they're really asking you to understand is that no matter what, when you have a y-intercept, the x value of that point is going to be 0. So we need to kind of discuss, why is that the case? Well, the case is, if we look at where the y-axis is in terms of the x-axis, so if we're looking right here, this is that point where the y-axis starts. And if you look, it's right at 0 on the x-axis. So no matter what point I have on this y-axis, the x value is always going to be 0. So hopefully that's making sense. What I'm going to show you now is how to use that information to your advantage. So when we know that we've been asked for the y-intercept, and we're going to start with the y-intercept part first, because in linear systems, we always care about the y-intercept more than the x-intercept. Caring about the x-intercept is actually something that will be more important in grade 10 when we learn about different types of functions. So in this particular case, it's really important that we understand that. And what we're going to do is actually just plug in the number 0 instead of the letter x. So what are we really saying there? Well, what we actually are looking at whenever we have a standard form equation is kind of just a jumble of numbers, but in actuality, what it really means is this is an unknown variable and this is an unknown variable. And we can use one of these to solve for the other one in a single point. So let's go ahead and do that. We know that at the y-intercept, the x is always 0. And if you're following along at home, I highly recommend you write this down, because the more you get this into your brain, the easier doing these types of questions is going to be. So let's plug in the number 0 instead of the letter x. Okay? And everything else in this equation stays the exact same. Okay, well now let's go ahead and do BEDMAS. And here we have a multiplication, because this was 3x, which actually means 3 times 0. And this is going to become 3 times 0, which is 0. And the rest of these, again, stay the same. So in order to solve for what y is going to be at this particular point, where x is 0, we have to now solve for the y variable. Well, the 0, because it is 0, sorry guys, because it is 0, it's just going to go away. And all we're left with is 7y equals 21. And now we just use our very simple algebra that we learned in grade 7 and grade 8, and we divide off the number 7, because what we're really solving for is y. And if you're confused about why we're dividing off 7, I highly recommend going back and really practicing your algebra, because this is something that's going to come up over and over again throughout the rest of high school math. And I know for a lot of kids, what really makes math difficult for them is the algebra, when in fact, if you just practice it and get those questions out of the way, you can have a lot of success. So 7 divided by 7 is 1. So that's what we've got. We've got 1y, which is what we wanted, and 21 divided by 7 is 3. So we have now solved for the y-intercept, okay? And what's very important is that we understand the following thing. The y-intercept would be right here, okay? That's our y-intercept. But more importantly, we also need to understand that this point happens at the point 0, positive 3. Because we are at 0 on the x-axis and 3 on the y-axis. And that's how we solve for this part. So this is the y-intercept, and as a point we write it as 0, 3. Okay? So now let's solve for the x-intercept. I'm going to do that over here. So just like how at the y-intercept, the x is always 0, well, the exact inverse is true for at the x-intercept. So at the x-intercept, the y value is always 0. And this is true no matter what kind of function you're doing. And as you get into higher grades, you'll see that there are fancier functions with much more going on. But just remember, this is so key. At the y-intercept, x is always 0, so we can literally plug in x and solve for y to get the y-intercept. And at the x-intercept, y is always 0. Wonderful. Okay, so let's take this same question and bring it over here just so that we can solve for the x-intercept. So remembering that what we're really saying here is that the y is always 0, well, all we have to do is solve for x by plugging in that value of 0 instead of the letter y. And if anyone is confused by this, please feel free to leave a comment, or if you're a scholarly elite student and your parent has access to our phone number, they can text the number. I am checking that kind of throughout. So if you have questions, feel free to send that in as well. So now that we've plugged in y as 0, we're going to solve for x, because that's really what we're looking for, is the x-intercept. Well, that's easy enough. We just know that 7 times 0 is 0, so that's going to cancel. And we're left with 3x equals 21. And then we just isolate for x using algebra. So we go divided by 3, divided by 3, 3 divided by 3 is 1, and then we get x equals 7. Okay? And that is our x-intercept. That is where on the x-axis the line is going to cross. So actually this right here is 7. So there we go. Plugging that in over here. Got my fancy line here. And now I also need to remember that we should be labeling, because the teacher in this case asked us to label. So this is at the point 7, 0. Just gonna bubble that off a little bit so that we can make sense of everything. So again, this point, the x-intercept is 7, 0, x, y. Okay, now we're not done yet because the teacher in this instance wants us to graph this. So all we've done is actually put 2 points down. What I'm going to do now is plug in one more point into my into my line equation, so that I can solve for that last point. So I'm going to go ahead and plug in the number 5, or no, let's do 3. So we've got we've got 3. Now remember, this is our original line. 3x plus 7y equals 21. And we're going to plug in x equals -3, because it'll just be easier for me to solve one last point so I can draw this line. So 3 times -3 plus 7y. And the reason I'm doing this is because when I plug in one number, I can solve for the other one. And if I know that my x is -3, then all I need to do is solve for y, and I'll know exactly where to put this point. So this becomes -9 plus 7y equals 21. And we're just going to go ahead and solve algebraically. So we're going to move negative 9 over and make it into a positive. So 7y equals 21 plus 9. And then 7y equals 30. And we're just going to isolate for y. So we're going to divide off 7 from both sides. And it doesn't give us an exact number. It's actually going to be a decimal, something like 4.2. But that's more than enough information because that's all I really need to know that this is going to be about here. Because that's my y value. So the value here is going to be negative 3, 4.2. And I can just now go ahead and draw my line. So I'm going to try to do this with my line value function guy here. So the arrow in this case should be going the other way. Let me try it. Let me see if I can get my line perfect. Yeah, it's hard for me to start from this way just because of the way that the nature of this drawing program, but oh, there we go, killing it. So these lines hypothetically go on forever, and that's why we have that arrow. So this line is going downwards, and we can just go ahead and label that 3x plus 7y equals 21. Okay, so I hope if you're following along and writing stuff down, you've had some time to write this all down. We are going to do the next part of this question because there was two lines given in this particular example that the student who submitted this was asking about. So I'm going to do some erasing here. So I'm going to erase starting from the beginning so that gives you some time to write stuff down. And if you weren't able to write this down, please do keep in mind that all of these videos from the live streams do get posted to the freemathhelp.ca YouTube channel, which is actually just the Scholarly Elite Tutoring YouTube channel. And you can go back and watch them again at your leisure whenever you have time. Okay, guys? Alrighty. So, let you guys follow that there. Give me 1 second. So, make some space here. We're going to do the next part of this question, which gives us another line to work on. And again, if you have questions, feel free to submit them in the chat. So, let's use a different color. And let's say I'm feeling fancy today. We're going to use this like magenta-ish color. So again, this isn't the exact example that the student submitted. We're doing something very, very similar. All of these things I'm saying still apply. If you're watching, if you're the student who submitted this, all of these rules still apply to the exact example that you sent in. We just, because whenever it is an assignment, we try to not step on any teacher's toes because we do work very closely with a lot of the teachers in the area. So we don't want to be fully giving you guys the exact answers to your submitted work problems, but we always want to answer the types of questions you're submitting so that we can give you an exact idea of how to solve them. Okay, guys. So this is the next line that we need to work on. So remember when we said that we had standard lines and they come in the form ax plus by minus c equals 0. Right? So again, we have a standard form line, we have an unknown x, an unknown y, and as you can see, these numbers correlate to these letters, and that just means that those are unknown variables when we talk about the line in theory, but right now we've been given real numbers. So just as we said before, when we're solving for the x and y intercepts, all that means is you're asking at what point on the x-axis or the y-axis does the line cross that axis. And no matter what, at the y-axis, the x value is always going to be 0, and at the x-axis, the y value is always going to be 0, just as we saw with our last question. So knowing that information, whenever I'm given a question like this, I can automatically say to myself, okay, well, if they want the intercepts, all I have to do is plug in 0 for the other term. So we're going to start off with the y-intercept, which again, oops, my writing. the y-intercept, x is always 0. Okay, guys, so what that means is we literally just plug in the number 0 for the letter x. So if we've got 5x plus 3y minus 15 equals 0, then all I need to do is literally plug in the number 0 instead of the letter x, and then go ahead and solve. So this question is slightly different from the last one because we have it equal to 0, and we're going to fix that very quickly. So first I'm going to go ahead and say, well, 5 times 0 is 0, so that's just going to go away. And now I'm left with 3y minus 15 equals 0, but that doesn't actually tell us anything right now. So in order for us to solve this algebraically, we're going to move this bad boy over the equation. The equal sign is what I'm trying to say. And you know that when we cross the equal sign, he becomes positive. So we go 3y equals positive 15. And then we just go ahead and solve for y by dividing that off. So this is something that I want you guys to be aware of, that this is something you can do. You can, when you have equations that are equal to 0, you can move stuff from one side to the other. It doesn't have to stay the way it is. Okay, and that's really the trick to solving these types of questions, is moving stuff over so that you can isolate for a specific number. So 3 divided by 3 is 1, and then we've got y equals 15 divided by 3, which is 5. So I now know that my y-intercept is 5, and that tells me also that the exact point that the y-intercept occurs at is 0, because that's the value we put in for x, and positive 5 for y. So that's right here. Very nice. So again, that's 0, 5. And be really good about labeling. I think for those of you who are in grade 9, it's really important to label, because it does get you those full marks, especially when the teacher says, you know, make sure to clearly label. And we have got to do the next step, which is where we solve for the x-intercept. So just like we learned on the last example, at the x-intercept, the y value is always, always, always 0. Okay, guys, so again, if we just write out the original equation that we were given, 5x plus 3y minus 15 equals 0, all we have to do is plug in the number 0 instead of the letter y. So everything else stays exactly the same, because what we're doing here is solving for x, and all we have to do now is first use BEDMAS to do 3 times 0, which is going to cancel because it's the number 0. 3 times 0 is 0 is what I'm trying to say. And then we're left with 5x and negative 15 equals 0. And just like we did last time, we're going to move negative 15 over, and it's going to become positive 15. And then we just solve for x. Simple as that. And 5 divided by 5 is 1. And then 15 divided by 5 is 3. So the x-intercept occurs at x equals 3, but the actual point where it's happening is 3, 0. And again, that's x, y. 3, 0. See that right here? This guy right here. So now, and again, this isn't something that the person's teacher asked for, but we are going to use one more point just because I like to be very exact. So this is 3, 0. So I am going to plug in one more thing, because all these equations are just ways of solving for points. That's really how I look at them, because when we think of them and try to make them more complex than they actually are, it can become very confusing. All you have to think of is that these unknown variables, so the x and the y here, are literally just there so that you can plug one thing in and solve for the other thing. Because if you know one thing and you have the full equation, you can solve for the other. So using that logic, we're going to plug in one more thing. So if I have 5x plus 3y minus 15 equals 0, I'm going to pick some random numbers, so let's go ahead and use the number 5 here as x. So looking right there. So I'm going to plug in the number 5 as x, so 5 times 5 plus 3y minus 15 equals 0. And 5 times 5 is 25 plus 3y minus 15 equals 0. So 25 is a number, as we know. So we've got 25 and negative 15, which are like terms. So we can rearrange this to be 3y plus 25 minus 15 equals 0. And 25 minus 15 is 10. So we're just going to go ahead and show that. And then we're just going to isolate for y using our algebra. So moving 10 over to the other side becomes negative 10. And then we have divided by 3y divided by 3y. And we get y equals negative 10 divided by 3, which is 3 point something, or negative 3 point something, sorry. Negative 3.3 repeated. So that's going to be somewhere over here, right about there, which makes sense because that's very much in alignment with our lines. So these are both negative equations, as we can see, because they're going from the left to the right. Okay, guys, so we'll just draw that line in. Very nice. Oh gosh, in that last second I ruined it. Yeah, see, they're very hard to draw with the straight line. I'll get it this time, I promise you guys. There we go. Very good. And then I'll just put that dot that I erased by accident. Okay, guys. So as you can see, we used all of this logical step-by-step information. And just to reiterate what I was talking about, when we've been given a line, so in this case the line formula was 5x plus 3y minus 15 equals 0, what we've really been given is an opportunity to plug one number in and solve for the other number. So if we know x, we can solve for y and vice versa. And when they've asked us for the x and y intercepts, we can always use the information that we know. So the y-intercept always has x as 0. So if you're looking for the y-intercept, just plug in x equals 0 like we did here. And for the x-intercept, the y is always 0. Okay? So there's that for you. Okay? So I'll just give you guys about 5 seconds to wrap up any writing down that's happening. And again, if you submitted this question, I highly recommend you write this down so that when you're doing your own problems, you can apply the same logic to your questions. Alrighty, guys? All right. So we're going to do the next part in a second here. Alrighty. So I'm going to leave this the way it is, and I'm just going to bring in a new line, or Cartesian plane as we like to call them. I'm gonna make this slightly bigger just so that you guys can see properly. Okay, guys, so the next question in this arena is converting from standard form into the y equals mx plus b form. So let's say we've been given 2 lines. I'm just going to type them in here. So consider, so line A would be something like 7x plus 4y minus 28 equals 0. And line B, let's just spread these out a little bit so you guys can see a little bit better. And then line B is going to be 5x plus, oh gosh, plus 2y minus 10 equals 0. So this is a question that comes up for every grade 9 student, no matter where you go to school in Ontario. Everybody has to know how to do this. So it is something that in my years of tutoring, I have covered millions of times. And I highly recommend in my work, like something I've learned over the years is just having a good idea of what the standard form is and what the y equals mx plus b form is really does help. So remember that standard form is in the form a of x, a times x plus b times y plus some number c equals 0. And we want to convert this into the y equals mx plus b form. And something that a lot of my students have asked me over the years is why? Well, because some nerd sat down and figured this out. That's just what math is. Some nerd sat down and made all of our lives super difficult, but that's okay because we're here to help. And really why this is the case is that we oftentimes want to solve for what the slope is, and the y equals mx plus b format is much more informative to us because it tells us the slope, and it tells us the y-intercept because the m is the slope and the b is the y-intercept. Okay, so that's why we do the conversion. Both of these formulas, both this one in the standard form and this one, if they've been converted about, like if it's about the same line, it's just two different ways of saying the exact same thing. Okay, it's like saying, for example, let me think of an example. So something like, I'll give you a weird example, but something like saying little brother and annoying person. You mean the same thing. They both are in reference to your little brother. Both of these things are going to be in reference to the same line. So given that information, let's talk about line A first. So line A from right here is 7x plus 4y minus 28 equals 0. And as you can see, it's in that standard form. Well, if we look at the slope form, let's see where the stuff is. So y is by itself on the left side, and everything else is on the right side. Well, that information is super important because we can actually go ahead and use that information to our advantage, because we can go ahead and isolate for y just by moving stuff over algebraically. So we're going to go ahead and do that. Here in this case, I'm going to move 7x over to the other side. And always, always, always double check before you move anything over, what is its sign here? Well, something that confuses a lot of kids that I've worked with over the years is, well, how do I know what the sign is? Well, in math, if there's no sign in front of a number, just like here with 7x, we assume that it's positive. So if on the left side 7x was positive, we can now move it over to the right side and make it negative. And the reason that happens is algebraic, and something that we're not going to cover here necessarily because it confuses some people if you've been taught algebra one way. So I'm trying not to mix the different formats of learning algebra. It is something that, if you want to work with one of our online tutors, they can walk you through algebra, and we have a lot of programs. We have a math mastery program that helps you understand the key fundamentals of math and walks you through all those important skills that you need. And it's very, very much something that definitely needs to be mastered by the time you finish grade 9. So if you're having trouble with that, just feel free to message us on our website and we can set you up with one of our online tutors. But let's go ahead and do that. So we've got 7x, we're going to move it over. So this is now going to be 4y minus 28 equals negative 7x. And then I'm also going to move negative 28 over because, as you can see, everything needs to be on the right side except for the y. So let's go ahead and move negative 28 over. And because it's negative here, on the other side, it's going to become positive. So this becomes 4x equals negative, 4y, equals negative 7x plus 28. Excellent. Now, what are we to do with this 4y? Well, we know that in the formula that we're looking for, which is y equals mx plus b, the y is just by itself. And in order to do that, we have to get rid of everything that's attached to it. And in this case, we have 4 times y. So the opposite operation is going to be 4 dividing that term. So we've got divide by 4. And actually, I'm going to show this in the next step just to make a little bit more sense for those of you who are writing this down. So just like we learned in algebra last year, when you do something to one side, you have to do it to the other side. And in this case, everything is going to be divided by 4 individually. So we've got divided by 4 here, divided by 4 here, divided by 4 here. You can also write this like this. 4y divided by 4 equals negative 7x plus 28 all over 4 because it's a common denominator. That being said, I don't recommend doing it this way because it's not going to be the most correct version of your answer for grade 9 math. Alrighty, so let's go ahead. 4 divided by 4 is 1, so that's going to cancel. And we're left with what we want, which is just y by itself. And what are we going to have here? Well, we have negative 7 over 4, which if I was to divide it, gives us some crazy decimal, and I don't want that. So I'm just going to leave the fraction, which cannot be reduced in this case, by itself, and then I'm going to put that in front of x, because it's negative 7 over 4 times x. And then here, 28 over 4 is actually just going to become 7. So we have gotten our answer here. Y equals mx plus b. If you think about it, this is in the exact format that we want. And our slope is negative 7 over 4, as you can see. And our y-intercept is positive 7. Alrighty. So the teacher in this instance wants us to graph this, so we're going to go ahead and do that. And the way that that works is as follows. So in this case, I already know one key piece of information, which is that positive 7 is our y-intercept. So I've got that down pat. And the way that I can solve for another point is literally just plugging stuff in. So I'm going to plug in the number 2 for y. The number 2 for x. So I'll go ahead and do that here. And we can just say, so y equals negative 7 over 4. Actually, I'll move this up just temporarily so we can kind of observe that. So y equals negative 7 over 4. And instead of the letter x, I'm going to plug in the number 2. And here we go. So I can solve for y now. So negative 7 times 2 is negative 14 divided by 4 plus 7. And obviously that's not going to give us an exact number, but we can reduce that to negative 7 over 2 plus 7. So that's going to be negative 3.5, but I'm going to leave this as a fraction just because that's easier. And then here, or actually, you know what? For those of you who are in grade 9 math, we'll just do this. Negative 3.5 plus 7, which is going to be 3.5. Okay, so the y value for when x is 2 is 3.5, so that's this point's going to be 2, positive 3.5. We're going to come back over here and plug that in. So 2, 3.5, right there. That makes sense. And I'm going to get one more value. Let's bring this down. So again, I'm going to just pick a random point and plug it in. So in this case, y equals negative 7 over 4 times, let's say 4 plus 7. And why am I multiplying it by 4? Well, what I'm asking realistically is where on the y-axis does this point land when my x value is 4? Alrighty? So that's just going to cancel, and then we have negative 7 plus 7, which is equal to 0, and lo and behold, without even trying, oh, not what I was trying to do. I have found our x-intercept, which is right here. So this is this line. Alrighty, guys? Just going to put my line value here. And again, we always want to be labeling. So we are going to go ahead and do that. So this right here is y equals -7/4 x plus 7. Alrighty, guys? So I hope that makes sense. Again, if you have questions, please feel free to leave them in the chat, is what I'm trying to say. Or again, if you are one of our Scholarly Elite tutoring students, feel free to have your parents send a text to the Scholarly Elite number. Okay, now we've solved this part. We have to also solve line B. So we're going to go ahead and make some space here. Hopefully you guys were able to write that all down. And if you missed the last couple weeks and you are on this unit right now, I highly recommend going back and watching the videos from the previous weeks. We have lots of lessons on how to do this stuff. So we covered this, and we cover word problems and a lot of other pieces of the analytic geometry unit that are really, really important to understand, and that you probably will be asked to know for the rest of high school. Okay, guys, so we're going to pick a different pen color just to make things a little schmazzy here, a little schnazzy. Oh gosh, it's so hard to pick these pen colors. I really get too invested in what the color is going to be. Let's do a green. Okay. So now for line B, which clearly got erased a little bit, that's a Y. So in line B, which we're doing right here, we've got 5x plus 2y minus 10 equals 0. And we always want to remember that when we're converting from standard form to the y-intercept, like slope y-intercept form, what we're really doing is just shoving everything except for y onto one side of the equation and leaving y by itself and using algebra to isolate for just one y. Alrighty, so keeping that in mind, let's go ahead and do that. First, I'm going to move over 5x. So what I'm left with here is positive 2y minus 10 equals -5x. And again, this was positive on the left side. I moved it to the right side. It became negative, which again is an algebraic thing and happens because it's the opposite operation. And like I said, we don't cover that in grade 9. That's more grade 7 and 8. But for those of you who might be struggling with algebra, I highly recommend practicing, because it will make a big difference in your success over the rest of high school. So now we're going to move over the -10, because again, what we're really saying here is that we want y to be by itself. I like to think of y as a guy who has the plague, or let's say he has coronavirus, and we just want to make sure that he's in quarantine. And that's really what is happening. We're trying to get y in quarantine. We're trying to move everybody away from him so that nobody else gets sick. So 5x. And then here, this was -10, so on the right side, it's going to become +10. And all that's left to do is get rid of y's attachment here. I like to call this guy here y's wife, or y's husband. We need to, as much as they want to stick around, we have to remove them. And the only way to do that is by dividing them off, because currently it's 2 times y. The opposite operation is dividing 2. And when we do something to one side, we have to do it to everything. So we're dividing by 2 across the board. This 2 divided by 2 is going to become 1, which is the whole goal. We want y by himself. And we've got y equals -5/2 x plus 5. So this is our y equals mx plus b version of this same thing. So as you can imagine, we did not change the line. Both this and this describe the exact same line. Like I said, they're just 2 different ways of saying the exact same thing, but one of them provides us with more useful information, because automatically we know that the y-intercept is going to occur at +5. Right there, as you can see, I'm putting it on the graph there. And let's just bring this down slightly. Oops. Slightly so you guys can see. So now what I'm going to do is figure out a couple other points, and all I need to do is just pick another thing. So let's again use +2, and I'm going to go ahead and plug 2 in as x, so I can solve for y, because everything is equal to y. So if I just plug in x, I can just pretty much automatically solve for y. And one thing that's nice here is I'm going to multiply by 2 in that case, and then these cancel. And magically, I have found our x-intercept, which is right here. And we're going to solve for one more. So we're going to go ahead and use 4 in this case. So negative 5 over, where is it? 2 times 4 plus 5, because I'm literally just, again, if this is our standard equation, I'm literally just plugging in number 4 instead of the letter x, so that I can solve for the y value of that particular point where x is 4. So what's going to happen here is negative 5 times 4 is negative 20, divided by 2 is 10, so negative 10 plus 5 is going to be negative 5. So that's another point here. Oops. So when when x is 4, I'm going to go down, and the y is 5. So these lines are very similar. Where's my circle? Or I mean my arrow. Oh, should have done this like that. There we go. And again, I managed to erase that point right there, but that's right there. So these lines do look very similar. Oh my gosh. Sorry, I'm going to try one more time, just so that we can have an actual straight line. There we go. Goodness. This is where my need for things to be perfectly straight in terms of how they look makes my life a little bit more annoying, but that's okay because we like to be precise. So this line right here has an equation, negative 5 over 2x plus 5. Okay, so the next part of this question that the teacher asked, I'm just going to pull this up here, was, well, they wanted you to graph the two lines. So you've accomplished all of this so far. You found the y equals mx plus b. You've now graphed them. And in the next part of the question, it says, compare the two lines. Which is steeper? Which starts higher or lower? So let's ask that first part of the question. So I'm just going to erase this stuff here, you guys, so that we can answer this question. So if I'm going to answer this question, so if I've got y equals negative 5 over 2, x plus 5, and then I'm just going to erase that so that I can show you guys the other one with the purple. Okay, and then this one is y equals negative 7 over 4x plus 7. So they want to know which is steeper. Well, we can solve for that. And, you know, some people might just want to look at it. But what we're really asking here is which of these numbers is technically going to give us more or a larger number. So what they're really asking is, in terms of the slope, when they ask which is steeper, which slope is larger? So we can go ahead and solve for that. When we know that the line that's purple has a slope of negative 7 equals 4, which is m equals negative 7 over 4, I can actually just plug that into my calculator and get negative 1.75. And then I know my green slope is m equals negative 5 over 2. And when I plug that into my calculator, which is negative 5 divided by 2, I get negative 2.5. And I see that this slope, the green slope, is steeper. And I can actually see that right here. If I was to look at these as slides, the purple slide would be a little less scary than this slide. So when they're asking which slope is steeper, they're really asking which of the two has a larger slope. Okay, hopefully that makes sense for you guys. Now, to answer the next part, which starts higher or lower? Theoretically, these lines go on for infinity, but given that your teacher is asking kind of based on what the y-intercept is, I would say that if you had to answer this question, it would be the purple line, because it starts higher, in the sense that it, what's it called? The purple line is higher on the y-intercept, if you're assuming that it starts at the y-intercept and goes from there. But that being said, if you were to look at these lines kind of infinitely, like if we were to do this, and to keep drawing this line, you know, kind of like that, I'm trying to make it a straight line, something like that. And then if we were to do this one in purple, and do this, oh, dang it. Why would it do that? Right? It's hard for me to make these lines perfectly straight, just because that's the nature of how the computer works. But you guys get what I'm saying, right? Like, if you're looking at these forever, asking which one is steeper is not really mathematically correct. But that's okay. So technically the green one, it starts higher in the long run, because if you think about it, even though it has a low y-intercept, that doesn't really matter because it is steeper. Okay. Again, that's kind of more complex. But if your teacher's asking you this kind of question, I would give a more extended word answer so that you can get the full thing. So okay, guys, that is the question that was submitted. I know that we didn't exactly get a chance to go into our lesson today, but that's okay. We are going to just quickly go over a couple of the things that we talked about today, so then make sure everybody fully understands. But if you do have questions, what I really do recommend, as you can see, this is one of the platforms that I use. This is not the platform that we use for our online tutoring. We actually use something where you have a video and audio connection with your tutor. You can see your tutor, and then if you have an iPad, you can actually write on iPad the same way that I'm writing on the screen. And your tutor has a graphics tablet like I do, so they can write very precisely on the screen, so you can see everything. And then your sessions are actually recorded, so you can go back and watch the session that you had with your tutor, so that you can always have those answers. So actually, in some ways, it's preferable to in-person tutoring, because you actually have a video recording of your session, which is really awesome and very, very helpful for people who want to go back and go over things that they talked about with their tutor, even when the tutor might not be with them in that moment. So again, a couple things that we talked about today, guys. Very, very important things for us to remember. When we are converting, sorry, I'm just going to make some space here for you. When we are converting from one format to the other, when we're converting from this format, which is our standard, equals 0, to the y equals mx plus b, literally all we're doing is just rearranging this thing. And I can show you guys what I mean by that, because if we're going from this to this, I'm going to show you how we do that just in terms of the letters. So again, we're trying to isolate for y. So what we're doing here is saying, okay, well then let's move everything else to the other side. So we're going to say this becomes negative ax, and then the next step is moving that over. So this becomes negative ax minus c. And then basically we want to divide off the b term, because we want y to be by itself. So we just divide b, divide b, divide b. This is what we call an algorithm. These are the steps that really you are supposed to be taking when you convert from standard form to y equals mx plus b form. You move everything over, and then you divide off the number that's in front of y. Okay, guys? So that's all that's happening, and then once we divide that off, b divided by b is 1, so we're left with 1y equals negative a divided by b x minus c divided by b. Usually you'll get a full number for this part there. And another way of saying that is y equals mx plus b, because this is m, this is x, this is that last part. Alrighty, guys. So to show you guys this same concept with numbers very quickly, so say we had, and I'm just going to use some random numbers here. So and I'm actually going to do another version in this case where the a term is negative on this side so that we can show you guys that it's not always going to be negative on the right side. If it's negative on the left side, then it becomes positive on the right side. So how does that happen? Well, it's not too crazy. All you have to show is, for example, if I had, negative 2x plus 3y plus 6 equals 0, then when I move over the negative 2x, I'm left with 3y plus 6 equals positive 2y, because again, I moved it over and it became positive. And now I'm going to move over this 6, so I'm left with 3y equals 2. Oh, gosh. My goodness. I'm sorry. This is not a y. This is an x. Goodness. Sorry about that, guys. That's an x. So now we have 3y equals 2x minus 6, because 6 was positive on the left side. It becomes negative on the left side. Wow, my brain today. It was positive on the left side. It becomes negative on the right side. And then I'm dividing off 3 from everything just to get y by itself. So we have y equals 2 over 3 x minus 2, because negative 6 divided by 3 is negative 2. Okay, be really careful with your signs. That's really where a lot of people tend to lose marks, is when they change it algebraically. But again, I highly recommend just brushing up on your algebra, you guys. It will make all the difference in your life. I promise. Y equals mx plus b. That's what's happening here. And in this case, the slope is 2 over 3, which means rise over run. And the b is negative 2. Okay, guys. So that's pretty much a wrap on this lesson. Like I said, if you are really struggling with this unit, this is a very important unit, and I highly recommend practicing your algebra. And if you are still confused, I really recommend trying out online tutoring. And again, it doesn't have to be with us if you're not one of our students. It can be with us if you want. We do have online tutoring, and we use the top of the line online tutoring system. It's not this system that I'm showing you guys here, but don't struggle in silence. The longer you wait to ask for help, the harder these questions become to answer, because you have new things that you're going to need to know. So it's very good to get this down pat before the end of grade 9. I know that you guys are not going to have exams, but whether or not you have exams this semester, you're still going to have to know this stuff when you go to grade 10 math. And this is one of the first units in grade 10 math is actually solving linear systems and solving the points of intersection of linear systems. So there's that. That's all I'm going to say on the matter. Also, I highly recommend for people, if anyone is struggling right now or you're having a really hard time emotionally, we are big supporters and really, really believe in Kids Help Phone. So if you're struggling, please feel free to go to kidshelpphone.ca. There's lots of people there who are more than happy to talk, whether it's through text or over the phone, about any difficulties you're going through right now. We know that this is a really crazy time, and sometimes you just need someone to talk to, so they are there for you. Okay, guys? I wish you all an awesome week. I hope to see you again next week, and have a wonderful day. So talk to you guys soon. And we're just going to switch over to the grade 10 class in a moment. Thank you very much. Okay, if you are tuning in right now and you're in the grade 10 class, I want to welcome you. Hope you are having a wonderful day and a wonderful week so far. We're almost at the end of this week, although right now in quarantine, it pretty much feels like all the weeks just blur into each other, basically. That said, you know, we're still here every Thursday to answer questions, and we will be pretty much until the end of the semester of this year so that we can help everyone with any math questions that they have. So today's lesson, just give me 1 second here. Today's lesson, we're going to kind of talk about a couple things covering quadratic graphs again, because now what we want to do is talk about quadratic graph transformations and how we actually apply that information for real life problems. So just give me 1 quick second here, you guys, to grab the information that I need, and we will get started right away. Okay? Alrighty, guys, and as always, you are more than welcome to submit questions in the chat. They don't have to be questions that have anything to do with the lesson I'll be teaching. They can be anything about any question you might have, even if it's totally different from the lesson that we're teaching. Today we're going to be talking a little bit about word problems and how we can use the knowledge that we've learned over the last few weeks to really just kill word problems and be really good at answering them. So I'm just opening up the material here because for some reason I put it back last night and did not actually leave it on my desk, but that is okay. We can solve this. So here we go. Done. Alrighty, guys, so again, I want to welcome you and I hope you're having a great day so far. Just gonna move that over. Awesome. So let's start with this word problem, which I don't like it when the problems are in the wrong color. So we're just going to go with the black color here. Alrighty, guys. So over the past few weeks, we have discussed a number of things. We've talked about vertex form. We've talked about converting between the quadratic form, the vertex form, factored form, and what each of those forms mean to us. And I don't mean like what they mean emotionally. I just mean, you know, what they tell us about a certain quadratic problem. So let's type this in here. Cannonball. Okay, I'll read it aloud to you guys in just a second. That's why that's happening. There we go. And T is the time on the stopwatch. So a lot of these questions are going to be about trajectories, which is what this one is about. And if you are taking physics next year, it's actually really good to have a strong understanding of what the heck we're talking about today, because this is actually a really big part of the physics for grade 11 curriculum. It's a little bit more complex in physics just because they're taking into account a lot of other factors in the physics curriculum, but it does help to have a strong understanding of what the heck this all means. Alrighty, guys. So let us move this over. Okay, so a cannonball is shot into the air and a spectator starts a stopwatch. An equation that represents the height of the cannonball is h of t. Sorry, that should just be 1 equals. Give me 1 second, guys. Is h of t equals 5t squared plus 20t plus 25. So as we can see, because it's a squared, we have squared in there, we do have a quadratic equation. Now, keeping that in mind, what we're going to do here are the two questions that they're asking us. So where h is the height of the cannonball in meters and t is the time on the stopwatch, they're asking us to find the zeros of this equation. And as we know from last week, which format tells us the zeros of an equation? That would be factored form. And not just last week, we've been doing this for a couple weeks now. Basically, in these first few weeks of freemathhelp.ca, we have been covering the most important and complex units for each grade. And then as we get closer to the end, we're going to cover a bunch of the other units as well. But I, as someone who has tutored math for many years, and I have a very, very, I would say, strong understanding of what it is that you really need to know from year to year, factoring is literally one of the most important skills that you need to master by the time you leave grade 10. If you haven't mastered it by the time you leave grade 10, you are going to have a harder time in grade 11. And I only say that because I've seen kids in grade 11 who have either forgotten how to factor or who never really mastered it in grade 10 really struggle when they don't have to because they're actually really smart kids. So let's talk about factored form. Well, I'm going to just take this question, the 5h of t equals 5t squared plus 20t plus 25. And for those of you who might have never seen questions with different letters other than x, another way you can say this is y equals 5x squared plus 20x plus 25. So when we talk about factored form, one of the first things that we're thinking of is that we need to determine if something can be taken out of all three of these things. Now, when we also are asking about the zeros, we are asking about the x-intercepts. So zeros, also known as x-intercepts. Okay, guys? So that's a really important thing to remember because we know from grade 9 math that whenever you're at an x-intercept, that y equals 0. And that's actually super important for us because that's how we're going to determine where this cannonball started and where it lands. Okay? Now, keeping that in mind, what we're going to do first is start some factoring in the factoring factory. So the number one thing I want to do is ask myself, is there something I can take out of each of these coefficients? And I know that I can because the number 5 can go into all three of these. So we're going to do that first by dividing out the number 5 from all three. And if 5 was a negative, I would divide it out as its negative because that's the a term. Because really what we're trying to do is we're trying to get into this format. X plus q. And what we've started with is this format, ax squared plus bx plus c. But the a term needs to stay the same in any format, even when you're looking at the vertex form, which we're not going to talk about right this second. You see that the a, no matter what, is the same. So if a was negative in the quadratic form, it has to be negative here in the factored form. In this case, it wasn't negative, so that's okay. But I just wanted to mention that in case anyone was unsure about that. So now that I've divided that, 5 divided by 5 is 1. 20 divided by 5 is 4. And that should have an x there, and then that's going to be 5. So this has now made this quite a bit better for us because we can go ahead and solve. Let me just double check one thing here. Oh, my bad. This was negative. Maybe that's why my brain kept bringing that up. So that 5 should be negative 5t. So this answer is going to be a little bit different. Let me show you what I mean. So again, like I said, you're dividing by negative 5. And typically when you have equations that have to do with like cannonballs and blah, 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 they're typically going to have a negative a term. So that was my bad, guys. Sorry about that. Alrighty. So we've divided out 5 and negative 5. And so that leaves negative 5 in the front. And then here this becomes 1 because negative 5 divided by negative 5 is 1. Positive 20 divided by negative 5 is negative 4x. And positive 25 divided by negative 5 is negative 5. Alrighty, guys. So now what we need to do is factor this part into separate factors. So what we really want is for it to be in this format, and we want two numbers that multiply to -5 and add to -4. So simple enough, we know that that's going to be -5, my bad, and +1. Okay, so we have now factored this. This is our equation. I'm actually going to put this back into the original format because, again, if you're doing this word problem at school, you are going to be required to be using the right letters. So we should be using T. Now, keeping this in mind, they've asked us for our zeros. So we've done step 1, which is put into factored form. Yay! Wonderful. Now what we're going to do is literally make all of this equal to 0. So we want to know at what point did the cannonball start when when the height was 0. So we want to know what time was it when the height was 0. So we're going to make everything equal to 0, -5, t minus 5, t plus 1. And what we're going to do now is separate these factors and make them each equal to 0. And this is a trick for the rest of all of math that you really need to be aware of. Whenever you're doing stuff like this and you have factors, you actually just look at each factor on its own. Okay. And now you just isolate for t. So we go t equals 5 because I moved 5 over, and t equals -1. So this is part A of this question. Find the zeros of this equation and what do they represent. So the zeros are -1 and 5. And what do they represent? So they rep the time when the cannonball was on the ground. Oh, that's going to be the word time. And I'm going to show you guys kind of a simple drawing that explains what I'm talking about. Okay. So this is a very common question that you will get, honestly, all the time. I've seen this on wow, my straight line's not bad. So really what they're asking is, just like with standard quadratics, they're basically saying, so what point was the cannonball on the ground? So if this is -1 and then this is +5, that's what they're saying. Alrighty, guys? So what that really means is that the cannonball didn't actually start at ground level, obviously, because I'm assuming it was angled upwards or something, so it would not have been exactly at ground level, meaning at time equals 0, the cannonball was a little bit higher than ground level, which we can figure out. So next thing we're going to do is solve the maximum height. So I'm going to let you guys have a second to write that all down, and then we'll do the next part of this question. And if you do have any questions about that, feel free to leave them in the chat. That's what the chat's for. And we're happy to answer them for you. Alrighty? So alrighty, guys. Gonna get that started. So let us move on to the next part of the question. So hopefully you had a chance to write that all down. And if you didn't, again, we do post these videos on our YouTube. The first couple weeks that we did are not on the YouTube channel just because we weren't originally separating the first 2 hours from the second 2 hours, and it was just way too long. It was like a 5-hour YouTube video. But now we are posting them every week. Alrighty, guys. So I'm going to erase all this stuff. Oh, no. Didn't mean to erase the word there. Okay. Just going to quickly get rid of that. I wish there was a way to make the eraser bigger. That would be nice. But alas, I guess I can't, or I just don't know how. So after last week, we had quite a few questions about our online tutoring and how it works. So I thought I would address that today. So we are a company that operates in Ontario, although we do online tutoring for kids all over North America. But we do offer online tutoring with a top-of-the-line system. We don't actually use this system that I'm using for the live stream for our tutoring. We actually have a very fancy system where you have audio and video capability where you talk to your tutor, and then you also are able to get a recording of your session. So in a lot of ways, it's actually better than in-person tutoring because you actually get to go back and watch your session again if there's something you want to refresh your memory about. And yeah, and so then you're able to ask the tutor questions basically in person because they're right there on the video chat with you, and you can upload questions you have. So it has a capability for everyone to upload PDFs. So if you have questions from class, we can do that as well. So I just thought I'd mention that because we had quite a few people ask us about online tutoring after last week. So I thought I would address that quickly. That said, the reason that we're doing this is because we know that not everybody has the financial capability to do online tutoring right now. Not that it's super expensive, but just I know that right now a lot of people's parents have lost their jobs. So that's why we're doing this, because I understand that not everyone has access to those same things. And we have a super exciting announcement in May that is going to help even more people get access to the tutoring that they need. So let's take a look at part B. So what is the maximum height of this cannonball? So in the last thing, we looked at factored form because when we look at zeros, automatically our brain should go bing, 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 factored form. In questions where they're asking you the maximum height, your brain should automatically say vertex form. So I'm going to show you two ways, one of which is kind of like a cheat way, but it's not really a cheat. It's just a much faster way of getting this answer. But if your teacher has given you this question, what they're really asking you to do is complete the square. So we're going to go ahead and do that. So if our question is h of t equals negative 5t squared plus 20t plus 25, we're going to do that first step. And again, if you're not familiar, you can watch our videos from previous weeks. We have videos on how to do this. We are going to go through the steps today, but if you want a more in-depth video on how to convert from quadratic form to vertex form, just go to the freemathhelp.ca website, and on the YouTube channel, you'll see that we have videos from previous weeks. So remember, the first thing we want to do is exile the C term. So I like to actually show this because it helps students remember to do so. So we're literally exiling him off the island. Goodbye. We don't need you anymore. And the next thing we're going to do is divide off the A term. So just off of these two things. And remember, like I said, if the A term is negative, you got to get him out of there as a negative. It's super important. Okay, guys? So we have negative 5 in the front. And what's left here? So negative 5 divided by negative 5 is 1. So that's just going to stay the way it is. And then positive 20 divided by negative 5 is negative 4 plus 25. Okay, guys, so remember, if you've watched other weeks, we talk about the death box. So this is where we take out negative 4 and put him into, or her. I feel like 4 would be a female, but again, we don't want to gender people. So we have negative 4, and we've got to multiply it by a half. And we've got negative 2 as our answer, and then we take negative 2 and we square it, which means multiply it by itself, and we get 4. So this is kind of a pretty straightforward one, but that's okay. We're going to take this 4 term and plug it back in as a positive and a negative. So we've got 5 times t squared minus 4t plus 4 minus 4. And this part stays the same. Now, remember that we only want to keep the positive part here. That's kind of the key to creating this perfect square, is by keeping only the positive that we brought back in. So what we need to do is get rid of the negative by multiplying it by the a term as we move it off of the island. So let's go ahead and do that. Negative 5 times negative 4 is going to be positive 20. So as we take it off the island, which inside the brackets is what I call the island, everything else stays the same. But over here, we're going to have positive 20 plus 25. So I'm already getting really close to solving the question that I've been given here, because that's really what they're looking for, is the maximum height, which is the y value of the vertex. So let's go ahead and solve for the rest. So we've got negative 5. And then here we're going to convert this into our other format. So we're going to take t minus 2 squared. Remember that we're taking this value and plugging it in exactly as it is back here into that perfect square. And this is going to add up to be positive 45. And if we recall, I'm just going to get rid of the death box quickly. Actually, you know what? I won't get rid of it because I know that for some people it's helpful. So I'm just going to move this up and over here. So if I'm looking at this in terms of my vertex form, which we know looks like this, and we know that the vertex is described as hk, and we know that the h term is always the opposite sign of what it is in the equation, and I'm looking at this format, which is h of t equals negative 5 t minus 2 squared plus 45. Alrighty guys, so in this case, not to confuse you guys, but basically this is going to be our h, so we know that that's going to be 2, because again it's the opposite sign, remember, and then this sign is the same, so it's positive 45. So this is our height, and in this case it's the max height because it's the vertex, and this is our time. So to answer our question over here, which is what is the maximum height of the cannonball, the maximum height is equal to 45 meters. And you would write this as a sentence, obviously, if you're answering this on a test or something, or on an assignment. And then the time at which this maximum height occurs is 2 seconds. I'm assuming it's in seconds. I think it said somewhere that's seconds. I'm going to assume it's in seconds. Time in seconds. Alrighty guys, so that is the answer to this type of question. When you have a question where it says, what is the max height of the cannonball? You need to put it into vertex form. You gotta find the vertex, and the height is usually the y, because if we think about logically, like if we have this and the cannonball looks like that, that's where it's happening. This is 2, and this is 245. Alrighty, so hopefully that makes sense for you. I'm going to show you guys kind of the cheat way to do this real quick. So I'm going to change the color of my pen. Let's say red. So what I mean by the cheat way is not that it's cheating. It's not actually cheating. It's just a faster way of solving for this, because you can actually very quickly solve for the axis of symmetry, which is the x value at which the quadratic equation is perfectly symmetrical. And it's much faster because then you just plug that x value in and you can go ahead and do that. So if we know that our equation in the quadratic form was y equals negative 5t squared plus 20t plus 25, which I think is the equation. Let me just double check. Yep, that's it. So there is a formula for the axis of symmetry where it goes x, the x value, is equal to negative b divided by 2 times a. So if we know that this is in the format y equals ax squared plus bx plus c, this is a, this is b, this is c, I can actually take those numbers and use them to my advantage. So I'm going to say b, well, I'm not going to say, b is actually positive 20. So I'm keeping this negative sign because the actual equation has a negative sign. Plugging in 20. If 20 was negative, I would plug it in as a negative, but in this case it's positive, so I plugged it in positive. And then 2 is part of my actual equation, so I leave that the same. And then the a value here is negative 5. So this becomes negative 20 divided by negative 10, which we know the negatives cancel, and this becomes positive 2, which we already know from over here, from right here, is our x value of the vertex. And then very simply, all I would have to do is literally plug in 2 as t, or x, whatever you want to call it. So the value of the height at 2 seconds is negative 5 times 2 squared plus 20 times 2 plus 25. So what we get here is negative 20 plus 40 plus 25, which equals positive 45. And that, my friends, this is the time, this is the height, and that is the answer. Okay? So hopefully that makes sense for you guys. If you are confused, just feel free to drop a question in the chat, and I can answer that for you. But yeah, this is kind of a quicker way to solve for that. And you'll often get asked for the axis of symmetry, and this is a formula which actually I've seen some teachers who don't teach the formula, but they ask kids to get it. And I think it's just because they don't want to give kids this faster way to do this. But I like to give people every possible way to do a question so that you can find the way that works best for you and then work backwards. I also use this to check my answers oftentimes for the vertex form. Because sometimes by the time you get to an end of a vertex form question, you're just like, what the heck? Did I do this correctly, or what's actually happening? So yeah. Alrighty, guys. So that's that. Hopefully, if you guys have any questions about that one, let me know. Just give me one quick second here. So I'll let you guys write that down quickly. And if you have any, I'll wait to see if anyone has any questions before we move on. I'm going to do a different type of question, and we'll see how it all goes. Okay, guys. So it doesn't look like anyone has any questions, so we're just going to take a look at a different type of question. So let me just get this out in order here. Okay. Sorry guys, I'm having some technical difficulties on my end. Just give me 1 second. Alrighty guys. So we have done a lot of questions that are both in the format of the vertex form, a lot of questions in the factored form. The other day we were talking about how equations are changed. And one thing I want to use the question that we just looked at to explain is transformations, because that's something we touched on a little bit last week, and I know that some people still wanted to go over transformations. And I think that when we use Real life examples is when things get a little bit confusing for a lot of people, so I want us to address those types of questions. So let's just bring this back up. So in this particular case, when we talk about transformations, vertex form often gives us the best sense of what the transformations are. So if we're breaking this down and talking about it piece by piece, let's just move this up slightly, and we're talking about this like, you know, negative 5t squared, negative 5t minus 2 squared plus 45 is y equal to y. So in this particular case, there are a couple things we have to address piece by piece, right? So the a term tells us a couple things. First of all, it tells us whether there's going to be a maximum or minimum. And in this case, because the a term is negative, we are going to have a maximum because the graph looks like this. And we know that because the graph is going downwards, it's going to have a maximum value, which is its vertex, which we solved for. And what's really important to understand is how to explain that. So in this case, the graph has been stretched by a factor of 5, and that stretch is vertically stretched, meaning if we're picturing it like an elastic band, it's been pulled upwards by a factor of 5. It's also flipped about the x-axis. So I'm just going to move that up so everyone can see. So it's been flipped about the x-axis because it's a negative. So that means that typically we know that quadratic graphs go upwards in their regular format. In this case, there's a negative a term, so it has been, it's like a mirror image flipped over the x-axis. In this case, we have a negative value here. So this means, let's do that. This means that it's been moved over, moved horizontally, or we can call it shifted horizontally. Horizontally by 2 units to the right. And why is it to the right? Well, it's simple enough to know because we know that in this case the vertex is at positive 2 because it's always the opposite sign, and that's the easiest way to remember that, is that it's moving in the opposite direction of the sign that it has in the final formula. Where's my, see what I mean? I'm having, for some reason my graphics tablet is acting up today. It's giving me a hard time. And then the positive 45 means that it has been shifted upwards by 45 units. Alrighty guys, so that's basically what's happening here. Please let me know in the comments if you have any questions. I'll give you a second to write that down. Okay. We have half an hour left, which is perfect. Okay guys, so again, I'm going to give you about 30 seconds to ask any questions you might have, and then we'll move on to our next thing. Alrighty guys, so we are going to move on here. Next question. So the next question we're going to do is something that a lot of people find really difficult, and it is kind of challenging. So I highly recommend, if you are following along, definitely write it down because it will help you out. Okay, so whoa, calipacity. What am I talking about? Capacity for each show. Okay, there might be some spelling errors in here, guys. Bear with me real quick. Okay. So, we have a common question here that I have seen pretty much with every student that I've ever tutored. Teachers have this type of question either on a test, and sometimes they wait until a test to throw this at people, and I think that's a little unfair personally because this is kind of a difficult question, but nonetheless, we are going to explain how to solve these types of questions. So you can basically determine that another question is like this one if you have a question similar to it on a test or something, if they're asking for you to maximize the profit. And the reason that we use the quadratic equations, quadratic formulas, I mean, basically, for these types of questions are because we know that in a quadratic, you do have a max value, typically. So how do we solve that using this gobbledygook information that has been provided to us? Well, let's go ahead and read the question. Sorry, guys, I just needed a sip of water. An auditorium has seats for 1,200 people. For the past several days, the auditorium has been filled to capacity for each show. Tickets currently cost $5, and the owner wants to increase the ticket prices. He estimates that for each 50-cent increase in price, 100 fewer people will attend. What ticket price will maximize the profit? So for those of you guys who are going into business or whatever, we talk about, obviously we want to maximize profits, and this is something that if you do go into business and you end up taking business calculus, you'll learn the calculus way to do this, which is actually a lot better. But nonetheless, we're going to learn this today. One thing to keep in mind as well is that when we're talking about maximizing profit, there are a lot of factors that we need to consider. First and foremost, we need to determine, just like when we were in grade 9, we were given like what we need to say our let statements are. So I'm going to say, I'm going to change this to black. I feel like my soul today just needs to have a black marker. Okay, guys. So let x represent something. So we need to determine what x is going to equal. Well, when I'm reading this question, I need to go through and say basically what is going to change. Well, here we're looking at this and it says two different things are going to change. When you increase the price, fewer people will attend. But they're saying for each 50-cent increase, which tells us, kind of like in grade 9 when we were looking at slopes, we know that each time something goes up by 50 cents, something else is going to decrease. So in fact, the x value should equal the number of times that you increase the price by 50 cents. So this is going to be number of 50-cent price increases. Alrighty. That's good to know. And if we already know what the price is, and we know that the price currently is $5, then the equation for the price would be $5 plus however many times you want to increase the price by 50 cents. So $5 plus 0.50x, which we know is a linear equation, but it could also be 1/2 of a factor. So that's going to matter to us in a moment. So this here represents the single price for a ticket, basically, depending on how many times you increase the amount by 50 cents. And if we know that right now the auditorium seats 1,200 people and it's full to the brim, and every time you increase the price, you're going to have 100 less people, well, the factor that's changing is still the number of times the price increases. So x is still what we actually care about. So here we're going to have 1,200 less 100 times x, which is basically the number of tickets sold. So I hope everyone's following along so far. This, like I said, is very, very common. If you haven't done this unit yet, you will see something like this. And even if you are done this unit and you didn't see something like this, you might get a grade 11 teacher who expects you to understand this concept. So it's very, very important that you guys get what's happening. So if you have questions, please feel free to leave them in the chat. Okay, guys? So let's take a look here. Basically, we know that profit, or income, I guess, is going to be represented, and you can call this revenue. Because revenue is how much you make before you take out your costs associated with stuff, right? But the revenue in this case is going to be the number of tickets sold times the ticket price. Well, lo and behold, we actually already figured out both of those things as equations. So let's go ahead and plug those in. So the revenue then is going to be number of tickets sold, which is 1,200 minus 100x times $5 plus 50 cents times x. Alrighty, guys, so let's go ahead and do that multiplication. And again, if you're feeling unsure about how that works, for the multiplication, we are just literally doing this like this. So it depends on how you want to do it. I typically like to do the x's first, but in this case, they're not set up that way, so it's okay. We'll do this times this. Alrighty. So we get 6,000. Oops. Like I said, sorry guys, I need to kind of figure out why my graphics tablet pen is acting up today, but it's okay. We'll keep on trucking. So then we have 1,200 times 50 cents, or 0.5x, which is going to be plus 600x, and then we go here negative 100 times 5, so that's negative 500x, and then negative 100x times 0.5x, which is going to be negative 50x squared. Okay, hope that makes sense for you guys. Now let's just bring this together. Back using this. So we are left with 6,000 plus 100x minus 50x squared. And if, for those of you who have watched previous weeks and maybe noticed that my writing is quite a lot bigger right now, it's because I just want to make sure people can actually see. So that's why I am writing quite a bit larger. Alrighty guys, so remember that we took so far to get to this point. If you remember our question, it's one of these maximizing the profit questions. So, you know, we had to represent x as the number of price increases, like literally the number of times you actually increase the price by 50 cents. And you're always going to be told in questions like these how much you're increasing it by. So when we multiply those two things together to get the revenue, as you can see, it is a quadratic equation, and basically we know that this quadratic graph opens downwards, which makes sense because we are looking for a maximum, and that's really important to note. So if we were to rearrange this, it would be negative 50x squared plus 100x plus 6,000, which makes sense. Alrighty guys, so if you remember what I was showing you earlier when we talked about the axis of symmetry, it's very easy to solve. You don't have to go in and do vertex form. You can, and like it's also something that I would do if this was on a test and you're looking for those maximum marks. But the point of this question, the point of us doing this question, is more to understand how to set this up so that you can get the right answer. So remember that our axis of symmetry is where you solve for the x value of the vertex. So the x is equal to negative b times 2a, and in this case that would be negative 100 divided by 2 times negative 50, which is literally just 1. That's it. So what does that mean? Well, A, we know that that's literally exactly where the graph, wow, my line. Wow, that was bad. Guys, I'm sorry. My straight line situation is not going well today. Pretend that that's like relatively well drawn, okay? Do me that favor. Alrighty, guys? Bless. So, if we're thinking about this in terms of how this is graphed and how it all looks, obviously we want to know, what is the maximum profit, because that's part of it as well. But most importantly, the question really asked us, what ticket price will maximize profit? Well, in this case, we know that the maximum profit occurs after one increase in the price, and that increase obviously is going to be 50 cents. But let's just first go ahead and take a look at that. So if this is where 1 is, right, to blah blah blah, and these x values represent price increases, obviously, or decreases, respectively. Keeping that in mind, I'm going to show you guys eventually like how we get to this, but let's say the maximum income should equal that. That's where this is happening. So this would look something like this. Mind you, this is not perfect, guys. Okay, bear with me on that, but this is what is happening. So basically, we got the x value of our vertex, and to solve for what the maximum profit would be, I could just literally plug that in, so we can show you that in a second. But the question itself was not asking for what the maximum profit is, it's asking you to solve for what the price would be. Well, that's simple enough. If we come back up here and we say that the price is represented by the equation $5 plus 50 cents times x, and I know that the maximum profit occurs when we increase the price by 50 cents one time, because that's the answer we got as the x value of the vertex, which tells us where the maximum is, then I can literally just go ahead and I'll say price that maximizes profit, and that would be $5 plus 0.5x, which then it becomes $5 plus 0.50 times 1, and that means that the maximized profit price is $5.50. That's the price that Buddy should charge to maximize his own profits, because it allows for the perfect combination of increase in price and also not reducing the number of people that would buy. Because as you know, human behavior, I don't remember who said it, but there's like a perfect quote about something like this that's like, human behavior en masse can always be statistically analyzed. Like, you can always know what the average man is going to do if you're looking at a large group of people, but you can never know what a single person is going to do. Beyond the point, Basically, that's what's happening here. And then if you want to know what the maximum profit would be, you actually just plug in 1 into this fully fledged equation here. So we just go ahead and go, I thought I changed the number, the color, I mean, there we go. It would be negative 50 times 1 squared plus 100 times 1 plus 6,000, and that comes to 6,050 as our y. So this is the number of price increases at 50 cents each, and this is the max profit to be attained when you do that. Alrighty guys, we're going to do one more example like this because these are quite difficult for a lot of people, and so I want you guys to be able to do this basically in the middle, like if someone was to wake you up in the middle of the night, you would still know how to do this. Alrighty guys, so let me just type out the next question here. Oh. When bicycles are sold for $300 each, a store can sell 60 a season, which doesn't seem like very good profit for that store, but anyways, let's just do it. For every $25 increase in price, it is estimated that the number of bicycles sold will decrease by 10. Similarly, if the price decreases by 25, the number of bicycles sold will increase by 10. So the question that they're asking is, find the price the store should sell the bikes for to maximize revenue. What is maximum revenue? Alrighty guys. So there are a lot of moving pieces in this question. Let's just take a look here. When bicycles are sold for $300 each, a store can sell 60 a season. For every $25 increase in the price, it is estimated that the number of bicycles will increase by $10. Similarly, if the price decreases by $25, the number of bicycles will be increased by 10. So unlike the last question, we actually have two options going on here. So we're going to kind of split this up and talk about each option separately. So this is option A and this is option B. So let's start with option A, but I'm going to write that over here too. Option B. Alrighty guys, so let's start with option A. First and foremost, just like our last question, we need to determine that we're letting x equal the number, hashtag means number of price increases at $25 each. Okay, so that's part one. So the price equation, well, we know that the price starts at $300, and if we're increasing it by $25 at a time, that's going to be this part of the equation. So that's price equation. And then we want the demand equation, which is going to be that a store can sell 60 in a season when the price is at $300. So we have 60, and here they've told us in part A, for every $25 increase in price, it is estimated that the number of bikes sold will decrease by 10. So if we start with 60 and we're decreasing by 10, that's 10 times the number of price decreases. So that's the demand equation. And let's do the same thing for option B. So again, option B, the same thing, except here we're going to let x equal the number of price decreases at $25 each. So here we have $300 minus 25 times the number of times you're going to decrease the price. And that's our price equation for option B. And then we have 60 bikes sold. And in this case, the demand increases as you decrease the price, which is that makes sense. People want things on sale. So if you decrease the price by $20, you have an increase of 10 people or 10 more bikes sold. So 10 times X. And that's the demand equation. All right, ladies and gentlemen. So let's go ahead and create that revenue quadratic equation that we started with. So 300 plus 25x times 60 minus 10x. And let's just go ahead and do that. So 300 times 60 gets to be some crazy numbers. So then 300 times negative 10. Sorry guys, I literally don't know why my pen is acting like this. So 3000x, and then here we have 25 times 60, which is positive 1500x, and then positive 25x times negative 10x. Okay, so that's going to be negative 250. And again, with these types of questions, you're essentially almost always going to have a negative a value. Like in this case, the a value is negative 250. That's pretty standard. Okay, so this final equation is 18,000 minus 1500x minus 250x squared. And you can write that however you want. You can rearrange this to be like this. All right, guys. X plus 18,000. So let's go ahead and do that on this side as well. So we've got 300. Oh, sorry, my bad. My bad. Should be minus 25x. And then we've got 60 plus 10x. And then those numbers should come out interestingly similar in some ways. So plus 3000x, that's going to be minus 1500x, and minus 250x squared. So the reason I'm showing you guys this separately is because if you see, it doesn't really matter, because these are the same thing but just the swapped version of each other. So in the end, it's going to give us the exact same overall quadratic equation. Okay guys, so even though we did two separate options, realistically the equation that matters to us in the end is the exact same. And the only reason it is because they're perfect opposites of each other. Like here you have 300 plus 25x, here you have 300 minus 25x, but on the other side you have 60 minus 10x, and then on this side you have 60 plus 10x. They're the exact same numbers, just swapped. So in the end, when you FOIL it out, you get the same final equation. Okay guys, so remember, for this type of question, all that really matters is using your axis of symmetry. So again, they're asking us to find the price the store should sell the bikes to maximize revenue. What is going to be and also what is going to be the max revenue. So first we're going to find the price, and the price we solve using x equals negative b divided by 2a, which is our axis of symmetry equation. Whoops. Alrighty guys. So that's our axis of symmetry equation, and we can just use that with this thing. Because remember, this is in the form of ax squared plus bx plus c. So in this case, we have x equals minus negative 1500 divided by 2 times negative 250. So let's go ahead and do that. So we have positive 1500 divided by 500, and that's going to be 3. So we're just going to move that up. So this x equals 3 tells us that we should be changing the price 3 times to maximize revenue. Alrighty? So keeping that in mind, there's actually a couple answers to that question. Okay? It means that we can either, so remember, 3 times, right? So if we're looking at our 2 price equations, we can either do this one where we go 300 plus 25 times 3, and in that we're going to get 375 as the price. Or you can go 300 minus 25 times 3, and you would get 225. Okay, so both of these answers are right. And if that doesn't make sense, feel free to leave a comment in the chat and I can address that. Both these answers are right. So we're just going to wrap this question up because we're actually at time now. But so that's the price. So the price can be either 225 or 375. So let's just write that down. Price depending on which of the 2 equations you're using. And then they would both give you the same answer in terms of max revenue. So maximum revenue can just be solved by plugging in x equals 3 into this equation. So let's go ahead and do that. So let me just get my, so we've got max revenue, and that would be y equals negative 250 times 3 squared minus 1500 times 3 plus 18,000. Oh, let me just move this over. 18,000. So let's go ahead and do that. So we've got negative 2250, and then we've got minus 4,500 plus 18,000. And no matter which of these you use, you've got negative 2250 minus 4,500 plus 18,000, and then we get our final answer for the revenue. Okay, guys? So that is that. This is our revenue overall. And I hope that that helped you guys. For those of you who might have this type of question, and you probably will have this type of question on an exam or on a test. I know you guys aren't having exams, but on a test, it will be very useful for you. So we are a little bit over time, but I'm glad that you guys stuck around because this is very useful information. You will need this even in future years. This is something that comes up again in calculus, in all sorts of math, and it's super important to understand how we structure these. Okay, guys? So thank you very much for joining. I hope you have an awesome day and a wonderful week. Stay safe, and we'll talk to you guys again next week on Thursday. So have a good one and talk to you soon. Bye.